in my belief system, cars will be so much cheaper in the future. So, kind of would like to hear your take on this, because what we're seeing in Europe, to give the background, set the stage, is that the European car companies mostly are making very expensive cars. We're looking at something starting at, I would say, 50,000 euros, 45,000 euros, and then upwards to 100, 150,000 euros. And if you look at the car park outside when I do grocery shopping, you can tell people that cannot afford these cars. And all of a sudden we got the BYD starting, Romania, or is it Hungary? We got the Geely factory in Slovakia. Um, there's a lot of things happening, but end of the day, my belief system is there must be electrical cars that will cost maximum 23,000 euros for the consumer on the street. Do you agree or do you not agree? Yeah.
Yeah, I think they're going to have to, and I think that's what you're going to start to see out of China. I think you're going to start to, right now, when you look at the Teslas of the world, at least here in the U.S., they came in at a very high price point, luxury, but they have slowly, with some of their more recent models, minus the Cybertruck, they have tried to meet more of a market that becomes more
Mm,
affordable. Now, as some of the traditional U.S. automakers who have been making the ICE engines are getting more into the EV market, that's going to force Tesla and others who make luxury vehicles. It's going to force them to operate in that lower price point market, because when you look at the
mm,
governments and what they're doing and trying to electrify the automotive industry, well, they still have to make it affordable. I mean, and you've
mm,
seen why there's been a little bit of a slowdown in terms of EV production because, well, number one, the infrastructure still needs to get built. That's first
mm,
and foremost. You still need to get buy-in from people to want to move to that. The climates are going to affect the battery performance, and then the affordability of it. So there's a long ways to go, I think, before there's full adoption of what the governments would like to see. But
mm,
yeah, absolutely, they have to come down in price to make these things more affordable to people, and create more buy-in. And so I think as more automotive manufacturers get involved, I think it is going to force more of a price point to compete with some of the Chinese manufacturers,
mm,
as well as some of the U.S. automakers that have production licked, that have know how to do production, and can keep their costs down. It's going to force those prices down as well. And companies like Tesla and the margins that they accept today versus what they're going to have to accept in the future when they have more competition is going to look a little bit differently. But they have to become more affordable. To your point.
I agree to that. I think one of the key drivers right now, I mean, a couple key drivers, it's, as Andy mentioned, it's reducing manufacturing costs. That has to happen. And I think, the next driver would be regulations that are occurring right now. So it's the market being influenced by governments saying, "Hey, your vehicles have to be more fuel efficient," which is great for
mm,
the environment, but they have to figure out how to do that. So they're trying to go to lighter weight materials, taking, one, cost out of production, and then making the materials, lighter, safer, and that's happening with this trend to aluminum frames, subframes, and all these aluminum components.
It's interesting. A little bit of not pushback, but I was at a recent convention talking to a tier one supplier to automotive for specifically castings. I mentioned Giga Casting to them, and they didn't push back on it, but they were one of those companies still trying to see how far and how quickly this trend is going to go. They haven't, let's just say, bought into Giga Castings, but let's just go and call it mega castings and start to modularize certain parts of
mm,
the car versus making the car one piece. What happens when the car is in a wreck, or what happens when you crack the front end? You have to replace the whole bottom part of it. So are they moving to larger parts? Yes, but maybe they want to modularize the car a little bit more. And I think that's something that we might be seeing, as opposed to, a full underbody or a front and a rear. Maybe they're going to modularize, the front quarter panel or the rear quarter panel or certain parts of the car, just because when there are accidents, what are you replacing? Because I'm hearing where there is pushback is within the dealerships and the serviceability side of it. Because when there is a collision or when their car does come in for damage and it's happening on the cast, well, how is a dealership going to handle that serviceability aspect of it? Now, Tesla can do it any way they want because they own and manage all of their dealerships here, at least in the US, and I'm assuming
Mm.
globally. So they can address that within their own dealerships, their own serviceability side of it. But when you get into the independent dealers of the larger automakers here in the US that are independent, then you've got some issues, and then you got to start to address how they operate
Yes.
and how they're going to be trained and how they're going to tackle those issues. So I think it has its place, but I still think the ideas are evolving, and companies are still trying to think of the best way to do it for themselves and for the consumer, but also their dealers as well. They're going to have to take care of the car once it's out on the road.
Mentioning the modularity. So if you put some modules, then you also increase the flexibility you need.
Yep.
Then that's basically the perfect entry point for you, just to say, okay, now today we producing these modules, let's load program ABC, and then we continue that. And especially when you see the prices of all these expensive tools, trim presses, and the size go up, that would be quite an impact, I guess.
That's a great point. You're moving away from these fixed assets to more of a, you change the program, you can trim the part. You don't need to find the trim press and change out the tooling. Great point, Fabian.
I've never been in a project where it hasn't been any tool changes between the first sample and the serial. And I've never been in a new product where it hasn't been a massive redesign of some corner of the damn product within a year after launch. Because, we didn't think about that. So why should I buy a trim press for what, 100,000, 200,000 euros, when I know that it will be obsolete more or less 6 months from now? I will do my PPAP sample, those 50, and then I do my other 250 for some pre-series for going up to Sweden at minus 40 degrees. Boom, boom. And then the engineer will say, you know what, we need to add some more material here, and we're pushing these towers at the 15 millimeters. And there you go. Then you're wasted. So I'll buy a torch, I think. I'll probably call Russ if I get into this. I mean, it seems to be the smart thing.
Yeah.
Definitely. But now the German side in me has to come out. And usually if you put heat and materials together, I cannot hide it. But heat and material together, that has an impact on the properties.
Yeah.
And a trim press doesn't put any heat into the material. What's your take on that? Because I think that's a typical questions for most foundries.
That's a typical question. And I said that the statement is, well, that's too good to be true. Now prove it. So we've been proving it. So aluminum materials used for structural automotive is different than, say, a standard like A320. So we've been doing testing with the industry players. We've been doing our own independent testing. And while I'm not the most technical, but so some of our results are, if we look at the heat affected zone around the cut, it's usually between 40 and 80 microns. And what is the conversion? That's less than 1 millimeter. And what we're finding as we look at, the microstructures is that it's more granular in these areas. And it's actually enhancing the material. So by becoming more granular, it's adding more ductility, more strength to the material around the edges. So it's actually a benefit to plasma cut, is what we found.
I mean, if you look at crack propagation, which is a very fascinating theme, if you go with a plasma, you should have a great reduction of the entry points for a crack propagation.
Yeah, you're the metallurgist here. You're probably speaking above
I'm
my
just
head.
giving you a sales argument, guys.
Yeah.
You're welcome.
Thank you. Thank you.
Yeah, we appreciate it.